Hello again. This is part 6 of monolithic versus layered. We talked about monolithic in details, and then we talked about layered prostheses, and we gave handling tips for both prostheses. Now we're gonna compare between them and see what's going on. Well, of course, first of all, you can't compare apples to oranges, as we know. Um, uh, it's imperative in any comparison to compare apples to apples and oranges to oranges. All right, what do I mean by that? We will give study-based facts about each type of prosthesis, and then you can make a better decision on what to use and which one is better to be used in this specific case. Okay, first of all, this is a monolithic crown versus a bilayered crown. You will see the layering here, many layers, and here you will see that it's a solid prosthesis, monolithic. All right, and it can be manufactured by this, can be manufactured by these processes. All right, like I said, monolithic, we give you the strength of each layer, but as a total strength of the multi-layer, it's hard to say. All right, now in general we can come up with general rules, all right, or general indications. Layered in general, it needs more reduction and preparation needed for layered. There's more reduction and preparation needed for layered. Higher in aesthetics, layered are higher in aesthetics, and they're not as strong. They have less strength than monolithic. Now layered are less compatible in certain cases, and the reason I say that because you don't want porous material, for example, under the pontic. All right, you better off have a full zircon or a full monolithic alloy, for example, touching the gum saddle than a porous porcelain material. So it is less compatible in certain cases, or the margin line, the 360 color or the lingual color, all of that, so it's less compatible in certain areas, the layered. Longevity of PFM, especially PFG, porcelain fused to gold, in many studies are the highest of all kinds. So the success rate, you're talking about the success rate of the layered, specifically the PFMs or PFGs. And here is the opposite. You need more reduction preparation for layered, you need less for monolithic. It gives you higher aesthetic, the layered in general. There's less aesthetics in monolithics, and we will discuss that furthermore. Less strength, more strength. Monolithic gives you more strength than layered. Less biocompatible. Monolithic are more biocompatible. Longevity of PFMs, there is no long enough studies up to 25 years of monolithic zirconia or monolithic lithium disilicates, all right, that I know of. But there is long studies, we will show both. Now, for example, look at this. The up to 25-year survival rate and a clinical performance of 2,340 high gold-based metal ceramics. It's a lot of prostheses. 2,340. The number of patients are less. It was I remember that. Here you go. All crowns provided to 670 patients, but the total of the crowns were 230 and 40 crowns. These crowns are high gold-based metal ceramics, PFGs, single crowns. All right, they're all porcelain fused to gold, single crowns. All right, and it's a 25-year long study. Now look at, it's between 1984 to 2008. Now look at the success rate. The up to 10 years and 25 years estimated survival rates of the 2,211 crowns were 97 point something, 0.08, 97% success rate in the first 10 years for the PFGs. Very high, 97%, it's amazing, all right? And then 85% success rate after 25 years. So even after 25 years of cementation of that PFG crown in the patient mouth, 85% was the success rate, which is amazing. It's just 25 years, what would you ask for more? A success rate of 85%, almost 86% success rate for PFGs. It is amazing. But the first 10 years it was 97% success rate of PFGs. Okay. Now, taking into consideration that you did everything up to the book, there isn't unsupported porcelain. Everything is done in the right processing sequence, you know. Now we have something about, there's a 10-year clinical outcomes for zirconia, for example, and it shows that the success rate, the 10-year success rate or survival rate for the zirconia frameworks of 91%. Okay, 91.5, 92%. So even on 10 years, there's 92% comparing to 97% in PFGs of success rate. So zirconia has a lower success rate on the first 10 years of performance. Now we really want to see after the 10 years of performance of zirconia, what kind of success rate does zirconia have? I didn't find any study longer than 10 years for zirconia. And bear in mind that there is low temperature degradation. There is aging for zirconia. So after 10 years, it's pretty old. I would say that the next 5 years, like say up to 15 years from cementation, that, you know, readings would be probably surprising. But I don't have any scientific evidence of so. Okay, those are the numbers that I have. Dull zirconia, 3 yttrium zirconia cores, lithium disilicate overlay. The term doped, zirconia doped with 3 molecules of yttrium. Okay. Now forget about the question. Let's look at this for now. Okay. Like I said, you will find many different ceramic classification, but I put this up not for the ceramic classification. Nevertheless, we can look at the ceramic classification. See, silica here is all the way up to here because it has any content of glass phase or silica. Crystal phase, lucite, zirconia, alumina, lithium disilicate, and it gives you, you know, the different company kinds, and then crystalline, doped zirconia or doped alumina of crystalline or polycrystalline, and then what kind of products does it have. What I really want to look at is the key here. We're going to talk about stacked, which is layered, which is veneered, which is built up. Okay, a core and a build up, stacked, and pressed, heat pressed, thermally heat pressed, an ingot. Okay, and then machined, CAD/CAM, computer aided design, computer aided manufacturing. Okay, CAD/CAM, and infused. The one that I told you, I'm not really sure what's infused. All right, but let's look at it now. The glassy or feldspathic, like I said, this is a different classification. They call this glassy or feldspathic or high in glass. All right, has lucite and silica in it, and it's Vita. And I said before, it's like Vita 13. Some people say it's Vita 9. Okay, whatever. But it comes only in stacked. Okay, so if you want the ultimate glassy feldspathic porcelain, you have to stack it over a refractory die or over platinum foil. Okay, so once you want the ultimate characterization, you go with feldspathic, and it's not pressed and it's not milled. It has to be stacked or layered or built up. Okay, that's what I want to point out here according to this classification. And then you have glass dominated. It's not glassy or high in glass, glass dominated. And then we have of that, like we discussed, the Empress 1, the Emax Zerpress, the IPS Emax Ceram. This is powder, and these 3 are pressed. Empress 1, Empress Aesthetic, Emax Zerpress. These 3 are pressed, heat injected. And then Empress CAD. There's a CAD/CAM here, Empress and Mark II. Okay, so the highest in glass is Empress CAD when it comes to CAD/CAM machine. Empress CAD, and like we said, Vita Block Mark II. All right, even though some people consider Mark II, like I said before, according to other classifications, as glassy or feldspathic block, they call it. But nevertheless, now we're talking about machined, stacked, or pressed. So now this is machined, CAD/CAM. This is CAD/CAM, Empress CAD, Vita Block Mark II CAD/CAM. And then these OPC and serenate, they are stacked, they are powders. Okay, then we move to crystalline dominated and crystalline. Crystalline dominated, we have IPS Emax CAD. All right, so this is lithium disilicate CAD. Over here wasn't lithium disilicate, it's mostly lucite. All right, Empress, like we said, Empress is lucite, dominated, and Mark Block 2. Those are not lithium disilicates. Once you move to higher strength, you're talking about lithium disilicate CAD, which is Emax CAD, and lithium disilicate pressed, which is Empress 2, which is the Emax, the IPS Emax press. Now it's called. Okay, so here's pressing, but higher of strength, up to 500 megapascal of strength. CAD cam up to 450 or 420, I'm not sure, megapascal of strength, the Emax CAD. But there is a different kind of injecting, not with Emax, but with lucite, and it's weaker. It's around 160 megapascal of strength. Okay. Now you move to crystalline, polycrystalline, whatever. There's Vita Alumina, Procera, Vita Deuterium Stabilized, IPS, Zircad that we talked about, zirconium blocks from Evoclar, Lava, and there's much more. There is Noritaki Kurari, and there is Dental Direct, and there is Mangerbach, and there is many blocks in the market. Many blocks in the market. Manufactured in Germany, in America, Korea, even China is manufacturing blocks these days. Turkey, the Middle East, different parts of Europe, Japan, you know. So there is much blocks of zirconia in the market that we will take a look at when we get to preparation guidelines and the different kinds of zirconia that can be used in aesthetic zone or in posterior functional zone. Okay, but I want you to see the different techniques that you can discuss with the dentist. Remember, in the first part of this video we talked about the importance of discussing not just type of work, all right, or type of material used, but as well we can discuss on a higher level, which is the way, the technique, because every technique and every way of making that prosthesis will give you specific indications and specific indications about physical properties, aging, translucency, cementation, etching, all kind of stuff. Okay, so it's a package. So I put this up for the key, so you know that some of it is stacked in different places, some of it is pressed in different places, different strength and different translucency, and some of it is machined in different levels as well. So you will find CAD cams in different strength and translucency, pressed different strength and translucency, stacked different, almost the same strength, but the difference in translucency. All right. Okay. So layered versus monolithic. Really, let's look at some cases. In this lecture, we haven't looked at much cases yet. All right. So let's look at some cases and try to figure out what kind of prosthesis these are. This is a 6-unit veneer. This is initial photo. The photos in the mouth are courtesy of Dr. Muhammad Nabilsi, but in the lab I took the photos. All right, he takes photos with Canon. I forgot which Canon, but I take photos with Nikon 7100. I use double flash or twin flash, and I use pocket bouncers. And some of the photos I take with polarized eye, and I have my own shooting techniques. I'm still working on it. It's not. I'm not. I need to improve in dental photography. But anyway, those are the doctor photos that he shared with me. This is my shooting. Now here, you see, this patient has broken teeth here. He lost much of the vertical here in this tooth and the other tooth, and there's diastema, and there's all kind of stuff. There's a filling here, and we needed to close the space in veneers. This is only veneers, all right. But let's actually go back. This will be discussed in details in my monolayered section of the lecture. But I just want you to look at it and try to figure out, do you think it's layered or monolithic? All right, I'm not going to answer that now. But look at it. Do you think it's layered or monolithic? Same thing here. Those are veneers, okay? I should ask you the question, do you think it's veneers or crowns? But those are veneers. BL2, bleach 2. In this region of the world, we manufacture or we use the bleach 1 and bleach 2 a lot, and people like very white teeth, and it's just not natural or whatever, but people like it, so we do uppers and lowers. See, this is like, for example, 20 upper, 20 lower veneers. All right, this is on the cast, and this is in the patient's mouth right after cementation. All right, so what do you think? It's layered. This is layered, but in a certain way. This is layered and this is thin, and I will show you. This is the same case. You see, this case is the same case. Now I'm going to show you in the middle of this lateral, for example, 0.4 millimeter of thickness, very thin veneers, and they are pressed, but I will tell you what's the mechanism of doing these layered you know, further in the lecture. This is with polarized eye, just to show you the amount of layering and everything. This is with a glove diffuser, and this is with pocket bouncers. But it's the same shooting, the same patient, and this is inside of the patient mouth, and this is on the cast. All right. How about these? What are these? These are same thing. I will show you the technique of how did I do it, but they are all the base of it is a pressed low translucent LT pressed ingot. Okay, layered study cases. I just want to show you that sometimes how much can you layer on a case like this. This is a veneer. This is barely prepared, right? The canine and the central is barely prepared. It's only a shell, only a veneer next to a discolored tooth. That's my shooting in the lab. This is the shooting in the patient mouth right after cementation, but it was done by a mobile. It's a mobile photo, right? With a mobile phone, so it's not that great, but it shows you that there is masking of the underlying high in stump shade central. The same thing here. Layered versus monolithic. We will talk about this. I'm trying not to give answers here because I want to go in details. How was this made? Okay. In my part of the lecture that's called monolayered. All right. So layered versus monolithic. Let's look at this because many people argue that you can't give a good monolithic with enough characterization. Like monolithic means dull, no life, no characterization. So let's just look at a couple of, consider this as a game. Let's look at a couple of photos, all right, in the patient mouth on the model, and try to guess which tooth or teeth is fake, which tooth is fake, or more than one tooth, and is it layered or monolithic. Just try to guess as I scroll down these photos, and then we will discuss them. Which tooth is fake? Which number, which tooth is fake? And is it layered or monolithic? Same patient, different views. Same patient, different views. One tooth is fake. It's this one. The upper right has very, very dark stump shade. This case was done, and this is with the polarized eye. This case was done with the technique that I will show you. It's fully pressed in whatever shade it was. I think it was A1 or B1, I'm not sure. I pressed it into B1 maybe, and then I stained and I layered in a certain way that I will show you. But the whole tooth was waxed and pressed in full, and then I performed my cutback in certain areas and did my layering in a certain way that I will show you. But this was layered, okay, if you want to say that. It was fully pressed as a monolithic and then cut back and layered in a certain way. We'll discuss that later. How about this case? In these two centrals, which one is fake? I want to make it easier for you this time. And is it layered? And what is it? Lithium disilicate? Oh, I forgot to say that this one is lithium disilicate. Okay, of course, pressed lithium disilicate. Right now, this one, which central is fake? And is it layered or monolithic? Okay, polarized eye photos. Closer look. It's this one, upper right as well. All right, it's the upper right, and it's an implant. And this is during me trying to take the shade of the gum in case I need to put gum porcelain, but I didn't need to. This is waxed up, castable abutment, UCLA, waxed up, because this implant was placed rather lingually, palatally, you know. So we left all of this in metal, thin, not very thin, but thin enough to go with, you know, with the patient's parameters here. And then we had an issue of the width of the central, but this is a layered PFM, porcelain fused to non-precious. All right, and that was the end result. Okay, so this is layered, yes, and that's why it was very easy to incorporate all kinds of textures and all kinds of internal coloring, bluish and whitish here inside of the crown, and the rest of it was done with minimally stain wherever the internal effects didn't work very well. We just stained a little bit. Okay, but this is layered. Okay, how about one more? There's no one more. This is a monolithic study case. I know that people that live outside of this region will see this as chiclets or very bright white, and it's not. And I agree with you. I wouldn't do this for myself, you know. As a patient, I wouldn't cement something like this in my mouth. But like I said, in this region, they love the super white. You tell them that the whitest thing on earth is BL1, they ask you, there isn't nothing whiter than BL1. I go, oh my god. So I invented a term that's BL0, okay? There's a BL0, a super white in a certain way. But anyways, they like the super white with no translucency and no internal characterization, just a chiclet, okay? So you can't do much. You can only give a little bit of characterization, a little bit of surface texturing, or what are you gonna do? I mean, it's one block of white stuff. And sometimes we do it like this, a thin veneer, 0.5 millimeter veneers, and sometimes we do it, so this is monolithic and glazed, only pressed and glazed, pressed, finished and glazed. And sometimes it's very thin, like this is, in certain areas, this was 0.2, all right? And it's pressed, we pressed it in 0.3, 0.4, but we reduced this because this was a non-prep veneer. This is like a laminate, if you wish, you know, a laminate veneer. Okay, a very thin veneer with no preparation. Now, what's monolayered? You know, in my lecture, the lecture, I give a live demo. So I layer and I stain, and I show the difference by giving a demo on layered versus monolithic, and I just stain and glaze the monolithic twice, and then I glaze the layered and show them the differences, you know. But we don't have a demo, a live demo here. We are up to the preparation guidelines, and then we will go back to talking about the monolayer technique that I do. But let's stop here so we can go into preparation guidelines in the next video. Okay, thank you for listening.